A pressure gauge is an instrument used to measure the pressure of liquid or gas. It typically consists of a pointer, dial, spring, spiral tubes, and connecting pipe. Liquid or gas enters the interior of the pressure gauge through the connecting pipe, and the pressure produced acts on the spiral tube or spring. The greater the pressure, the greater the deformation of the spring or spiral tube, which in turn causes the pointer to rotate through mechanical transmission and display the corresponding pressure value on the dial. Pressure gauges are widely used in various fields such as industry, agriculture, chemical industry, petroleum, fertilizer, metallurgy, and electricity to measure and control the pressure of various gas and liquid media. According to the measurement principle and usage scenario, pressure gauges can be divided into the following categories. Mechanical pressure gauge. Mechanical pressure gauges usually use springs or steel plates as deformation elements. When pressure is applied to the deformation element, it will cause bending or stretching of the deformation element, thereby driving the pointer to move and indicating the pressure value of the measured medium. Hydraulic pressure gauge. Hydraulic pressure gauges use a liquid pressure sensor to convert the pressure of the measured medium into liquid pressure, and then convert the liquid pressure into mechanical displacement or electrical signal, so as to obtain the pressure value of the measured medium. Electronic pressure gauge. Electronic pressure gauges use a pressure sensor to convert the pressure of the measured medium into an electrical signal, which is processed through amplification, filtering, AD conversion, etc., and finally displays the pressure value of the measured medium. Differential pressure gauge. Differential pressure gauges used to sensing pressure tubes to measure the difference between two pressures, thereby obtaining the pressure value of the measured medium. Vacuum gauge. Vacuum gauges are mainly used to measure the pressure under negative pressure. Its working principle is similar to that of a mechanical pressure gauge, but the measuring range is generally between 0 and -1 atmosphere. Thin film pressure gauge. Thin film pressure gauges use thin films as deformation elements. When pressure is applied to the thin film, it will cause deformation of the thin film, thereby driving the pointer or sensor to output a signal and obtain the pressure value of the measured medium. Choosing well-known brands and high-quality pressure gauges can ensure measurement accuracy and service life. These brands include O&Kmarts, Ashcroft, Omega, Yokogawa, Emerson, Honeywell, Parker Hannifin, SMC, Festo, and OSHOK, XGZ, and so on. After purchasing, there are several points to note when installing a pressure gauge. Installation location. The pressure gauge should be installed on the straight pipe section where the pressure is measured. Installation direction. Generally, the pressure gauge should be installed perpendicular to the direction of the measured pressure. Connection pipeline. When installing the pressure gauge, attention should be paid to the pipeline connection method and pipeline material to prevent leakage or pipeline rupture. Installation environment. Avoid installing in environments that are too hot, too cold, humid, or susceptible to vibration interference. Calibration. After installation, calibration is required to ensure the accuracy of the pressure gauge reading. As for specific installation steps, because different models and brands of pressure gauges may have some differences in installation, it is recommended to first check the instruction manual of the pressure gauge before installation and follow the instructions.